In this video, we'll complete the investigation for trigonometry. Okay, derivative of trigo function, derivative of y cosine x. We use first principle. F prime x equals the limit. F prime x, sorry, A. Okay, yeah. F prime x equals the limit of fx plus h minus fx over h. And then fx plus h is sine x plus h. Okay, so please take note. This is not fx plus h. This is fx plus h. Okay, you see the difference. If it's fx plus h, x plus h in the bracket, that means x replaced by x plus h in the bracket. So we have sine x plus h minus sine x over h. Okay, now from here to here, this is using the compound angle formula. Okay, sine A plus B is sine A cosine A plus, sorry, sine A cosine B plus cosine A sine B. Okay, so sine A, sine x, cosine B, cosine h. Sine B, sine h, cosine A, cosine x. Okay, and after that, we do a combination. What we combine is this part. Okay, this part, if I combine, it is, sorry, find the wrong one. What I combine is this one, and this one. Okay, so these two. Okay, that is sine x cosine h minus sine x, which is sine x cosine h minus 1, that is negative sine x, 1 minus cosine h. Okay, so that's why you see negative sine x, 1 minus cosine h is from this and this. Okay, and then plus sine h cosine x, this one leave it alone. Now we separate, because here we got the plus sign, so we separate this into two limit expression. And then for the second one, sine h over h, sine h over h times cosine x. Cosine x can be taken out. We just need to work out the limit of sine h over h. For this one, sine x is independent of h. Okay, only h goes to 0. Sine x is not affected. So this sine x also go out, become minus sine x times the limit of 1 minus cosine h over h. As we know, this one has a limit of 0. This one has a limit of 1. So we have negative sine x times 0 plus cosine x times 1, which is just cosine x. So we prove that when fx equals sine x, the derivative of sine x is cosine x. And you can see, if I don't know the limit of sine h over h, if I don't know the limit of 1 minus cosine h over h, you cannot get the derivative. That's why in the previous investigation, we spent so much time, used a few different methods to prove their limit. Okay, same as second one. Fx equals cosine x. F prime x equals cosine x plus h minus cosine x over h. And then cosine x plus h, once again, we use the compound angle formula. Cosine A plus B is cosine A, cosine B, minus sine A, sine B. And that's why we have cosine x, cosine h, minus sin x sin h. Okay, here is a little bit special. Cosine is a plus, and here is minus. Okay, so cosine x, cosine h, and minus cosine x come together. Minus sin x, sin h, put the other side. Okay, so this negative sign put here. Okay, so cosine x, cosine h, minus cosine x, we find the limit. Then minus the limit of sin x, sin h over h. Cosine x, once again, taking out. Sin x also take out. Now, this negative cosine x times limit of 1 minus cosine h over h, because this limit equal to 0, so negative cosine x times 0 becomes 0. And then here we have a negative sin x times the limit of sin h over h, so we have negative sin x times 1. Finally, our answer is negative sin x. So once again, using the limit of 1 minus cosine h over h and the limit of sin h over h, we manage to prove when y equals cosine x, dy dx equals negative sin x. Yeah, although you know these two formulas, you might have known these two formulas previously, but in our syllabus, you still need to have the knowledge how these two formulas were proved, established. Okay. So that's the purpose of this class investigation, to show you how we know that the derivative of sin x is cosine x, and how we know that the derivative of cosine x is minus sin x.